Let's be honest for a second. When was the last time you actually thought about your water heater? For most of us, it's just this big, ignored metal cylinder hiding out down in the basement, right? You literally only remember it exists the morning you step into a freezing cold shower. But I want you to really think about this. Is your home's water heating system secretly a complete relic? Because the truth is, that old tank might be quietly wasting an enormous amount of energy and money right under your nose. Well, welcome to this explainer on the 2026 Water Heater Buying Guide. Today, we're taking a pretty dense, highly technical engineering document and translating all those complex specs into a totally clear, actionable blueprint for your home's future energy architecture. The era of the low-efficiency electric resistance tank, yeah, that is officially coming to a close. And what's replacing it is nothing short of fascinating. Because we've got some advanced thermodynamics to cover, here's our roadmap for today. 1. The water heating paradigm shift. 2. Rethinking efficiency and sizing. 3. Breakthroughs in 2026 technologies. 4. Global engineering philosophies. And finally, 5. The expert selection matrix. Starting with Section 1, the water heating paradigm shift. So, upgrading your system is no longer just a simple capacity calculation. Actually, scratch that. It's not simple at all anymore. It is now a massive infrastructural decision. The choices you make today are going to dictate your home's long-term utility bills, its total carbon footprint, and even how it interacts with the broader energy grid. We are moving way past simple appliances here. We're talking about sophisticated energy management nodes driven by decarbonization mandates and advanced AI. Let's move to Section 2, rethinking efficiency and sizing. Okay, to make that strategic choice, we have to talk about the Uniform Energy Factor, or UEF. It's the gold standard for measuring efficiency, and it brilliantly illustrates the sheer power of multipliers. So traditional electric resistance tanks, they maxed out at a UEF of about 0.95, meaning they converted 95% of their electrical energy into heat. Not bad, right? But modern heat pump water heaters, they routinely hit a massive 4.0 UEF. How is that even possible? Well, they don't generate heat from scratch. They just move ambient heat from the air into the water. For every 1 unit of electricity used, you get 4 units of thermal energy. That is an absolute game changer for your ROI. Now, sizing these things operates on fundamentally different physics today. For tank-based systems, your critical metric is the first hour rating, or FHR. A typical 4-person home usually needs an FHR of around 65 to 80 gallons. But if you look at the tankless side, it's a completely different ballgame. It relies strictly on flow rate, gallons per minute, and the required temperature rise, which engineers call delta T. To put that into perspective, if your incoming winter groundwater is a freezing 50 degrees and you want a 120-degree shower, your system has to achieve a delta T of 70 degrees. That massive temperature lift will significantly cut the actual gallons per minute a tankless system can push out, which is absolutely crucial to know before you buy. All right, Section 3, Breakthroughs in 2026 Technologies. Let's get to the really fun part. When you look at the core 2026 technologies, these definitely aren't just heating coils in a bucket anymore. They incorporate wild fluid dynamics and advanced phase change refrigeration cycles to hit unprecedented performance levels. Let's break down the absolute heroes of this technological leap. The biggest standout in modern heat pumps is the shift away from harmful chemicals to natural refrigerants, specifically R744, which is just carbon dioxide. CO2 refrigerants have a global warming potential of literally 1. But what makes this so incredible is the transcritical refrigeration cycle. Basically, it's a high-pressure system that lets these units safely rip thermal energy straight out of freezing air. No joke. They can work in environments down to negative 15 degrees Fahrenheit, producing perfectly hot 140-degree water, all without ever needing backup electric resistance elements. But hey, what if your home is sticking with gas? Well, the absolute pinnacle there is condensing tankless architecture. Older, traditional systems exhaust their flue gases at over 300 degrees, just wasting tons of thermal energy right out the chimney. But the 2026 models use secondary stainless steel or titanium heat exchangers to capture that heat. As the water vapor in the exhaust condenses, it releases hidden, latent heat to preheat the cold water coming in. This pushes their thermal efficiency to an incredible 98%. Plus, their zero-emission premix burners pretty much eliminate nitrogen oxide emissions entirely. Now, what's truly mind-blowing here is how software is literally turning hardware into energy storage. We call this grid interactive water heating. These systems use AI algorithms and Wi-Fi to talk directly to the smart grid. They act as thermal batteries. The The AI actually learns your daily habits. It knows you take a 7 a.m. shower, and it cross-references that with local weather and grid pricing. So if solar power on the grid is super cheap at 2 p.m., it will superheat your water to 150 degrees using a mixing valve to make sure it comes out of your tap safely at 120. You're effectively storing cheap, clean energy to coast right through peak evening prices. And to make sure these massive investments actually last, we are finally seeing the end of the traditional sacrificial anode rod. You know, those magnesium sticks you were technically supposed to replace every few years but definitely never did? Yeah, those. The industry is moving to permanent 316L stainless steel tanks. Or, for glass-lined tanks, they're using impressed current cathodic protection, or ICCP. It's a specialized titanium probe that injects a precise, tiny microcurrent into the water. This perfectly counteracts the reaction that causes rust, effectively extending the tank's life indefinitely. Next up, Section 4, Global Engineering Philosophies. How these technologies are applied really depends on where they're engineered. In the Americas, the philosophy is all about ruggedness and smart electrification. Brands like Rheem totally dominate by offering 120-volt plug-in heat pumps. This is huge, guys. It allows you to replace an old gas tank without the crazy expensive cost of upgrading an older home's electrical panel to 240 volts. A.O. Smith focuses on extreme durability and whisper-quiet compressors, while Bradford White builds units specifically tailored for quick, straightforward contractor maintenance. Over in Europe, engineering giants prioritize extreme efficiency and zero-carbon innovation, mainly because space is way tighter and energy is way more expensive. Bosch leads the pack with ultra-compact units using anti-scale geometry. Stiebel Eltron uses these crazy proprietary vacuum insulation panels to keep standby heat loss unbelievably low. And Violent? They are pioneering CO2 heat pumps designed to directly integrate with your domestic solar panels, giving you the ability to run your water heating entirely off-grid when the sun is out. Meanwhile, Asian manufacturers focus intensely on microcogeneration, which means generating heat and power at the same time and optimizing for incredibly dense urban environments. Rinnai and Noritz are pushing boundaries with flagship models that have hydrogen-ready burners. Navien brings these massive 15-to-1 turndown ratios, meaning the burner can fire at a tiny, tiny fraction of its capacity just for a single running faucet, totally eliminating wasted energy. And brands like Panasonic deliver eco-cute, ultra-high-temperature split systems that are just perfect for dense apartments. And finally, Section 5, the Expert Selection Matrix. So how do we synthesize all this engineering jargon into a final purchasing decision? We map it directly onto an expert selection matrix that perfectly balances your household's infrastructure against the physical requirements of the tech. For example, if you have a warm basement and a smaller family, a standard heat pump is phenomenal, though it does need enough air volume to pull heat from. Got massive shower demand but tight space? Condensing gas is your winner, but remember, it needs PVC venting. And if you're replacing a gas unit without wanting to do an electrical upgrade, the 120-volt heat pump is the way to go. Just be prepared for slightly slower recovery times. It's honestly like a giant puzzle. Matching your specific, unique scenario is absolutely everything here. A household with solar panels and a big, moderate climate garage? That is the absolute perfect candidate for a heat pump. But if you have space constraints and you need infinite hot water because 3 teenagers are showering at the same time, condensing gas is technologically supreme. It's all about finding that perfect intersection between your physical space and your daily load demand. But hey, before you pull the trigger, keep these 3 insider engineering tips in mind. First, the hard water variable. If your water hardness exceeds 7 grains per gallon, you absolutely must pre-treat it or buy a stainless steel tank. Otherwise, scale is going to destroy a tankless heat exchanger so fast. Second, for larger homes, look into crossover recirculation loops. They push water back through the cold line, so you aren't dumping hundreds of gallons down the drain waiting for it to get hot. And third, if you're upgrading to a condensing gas unit, make sure you plan to completely abandon your old metal flues for dedicated PVC direct venting. So, what's the big takeaway from this explainer? It's this. You have to synthesize your specific delta T requirements, your home's electrical capacity, your venting routes, and your local water chemistry. If you actually account for all those variables, you aren't just buying a metal box that makes water hot. You are fundamentally future-proofing your entire property against rising energy costs and changing grid regulations. Ultimately, by leaning into these advanced technologies, whether it's CO2 refrigerants pulling heat out of freezing air, or AI acting as your home's personal thermal battery, you achieve what the experts call an unparalleled standard of domestic comfort, operational longevity, and environmental stewardship. Which leaves us with one final thought. We've seen how a simple tank can now think, communicate, and store clean energy. So the only question left is, are you ready to stop just burning fuel in the basement and start turning your home into a dynamic, energy-saving node on the smart grid? Thanks for joining me on this explainer. Go take a look at your basement, do the math, and welcome to the future of home infrastructure.